Okay, say you work for a fertilizer company and your job is to make ammonia. So you take gaseous nitrogen and hydrogen and you make ammonia. And for this particular lab, this particular batch, you have 32 grams of nitrogen. You'd like to know how much ammonia you can make with 32 grams of nitrogen. This is the section to help us answer those sorts of questions. It puts the last two sections together, and it's a multi-step process. If we start with grams of A, we can convert into moles of A. Then we have tools in our toolbox to convert moles of A into moles of B, which is a completely different compound, like taking nitrogen, moles of nitrogen, and converting it into moles of ammonia. And then finally, we also have in our toolbox tools that will allow us to take the moles of B and change it into the grams of B. For this first conversion, we'll use the molar mass of A. For the second conversion, we'll use the mole-to-mole ratio. I showed you mole-to-mole ratio in the last section. This was the recipe method. You go back to the balanced equation and you see how many moles of A interact or make moles of B. Lastly, if we have moles of B, we can use the molar mass of B to convert to grams. Okay, so that's kind of an overview of what I'm going to be doing. Let's look at our first problem. Suppose we want to determine the mass, that's grams, of ammonia that can be produced from 32 grams of nitrogen in the following equation. So what we're going to have to do is we'll start with our 32 grams of nitrogen. We have to convert our grams of nitrogen into moles of nitrogen. Moles of nitrogen. We can then convert our moles of nitrogen to moles of ammonia, CH3, and then we'll take our moles of ammonia and convert them into grams of NH3. Okay? These are the ones we don't know. Okay. Well, why can't I just take grams and convert it into grams? That's because you can't do that because in our balanced equation, things interact stoichiometrically. They act by number of particles. So by going into moles, you're changing it into the number of atoms of nitrogen, and that relates to the number of atoms of ammonia that you can produce. You cannot skip the steps where you take grams to moles and moles back to grams. So it makes a three-step process. All right, so let's start. Let's write in our conversions. 1 mole of nitrogen gas is going to be 28.02, I think. Okay, we can look up here and see that 1 mole of nitrogen is going to make 2 moles of ammonia. So we've got, I'll use a different color, 1 mole of nitrogen is going to equal 2 moles of ammonia. And lastly, we'll get a red out. We'll need the molar mass of ammonia, so that 1 mole of of ammonia is I've got to 17. I think I rounded a little, 17 grams. Okay? So we have 3 conversion steps, and for each conversion step I have an equality that relates the characteristics together. This is grams. Okay, so we've got our plan. Grams of nitrogen to moles of nitrogen to moles of ammonia to grams of ammonia. So let's go through the steps. We'll begin with our 32 grams nitrogen. We'll need to convert our grams of nitrogen into moles of nitrogen, and we will use the molar mass to do so. 1 mole of nitrogen is 28.02 grams, and so we want grams to disappear. I'm going to put the 28.02 grams in the bottom, so we'll have grams over grams. That'll make them go away, and we'll put the 1 mole of nitrogen in the top. So we do the math here. We end up with 1.14 moles of nitrogen. Okay, so we can take that information our 1.14 moles of nitrogen. We now want to take our moles of nitrogen to moles of ammonia. And to do that, we use our, that's the hydrogen. We'll use the 1 mole of nitrogen and the 2 moles of ammonia. I could also use the recipe method here if I wanted to, but we're going to use the coefficients. Okay, so we want moles of nitrogen to disappear, so I'm going to put the moles of nitrogen in the bottom, and I'll put my 2 moles of ammonia in the top. So I'm going to end up with 2.28 moles of the ammonia. Nitrogen will have canceled out, and 1.14 times 2 is 2.28. Okay. We'll take this number then, the 2.28 moles of ammonia, using the molar mass of ammonia, which we calculated up here, is 17. We've got 17 grams is equal to 1 mole of ammonia. So I'll take my 2.28 moles of ammonia times 17, and I'll end up with 38.76 grams of NH3, or ammonia, sorry. Okay, so it's a 3-step process. The first one, we got moles of, which we took our nitrogen and put it into moles. Then we used our mole-to-mole ratio, and then we went back out of moles into grams. In this next problem, I'm going to show you how you can stack these equations and make them make it a little easier on yourself. It's like in this problem, we're starting with 45.8 grams of our iron oxide. Lots of rust coming out here. And we'd like to know how many grams of oxygen. I'm giving myself lots of room, so I can write grams of oxygen. We're going to need to change iron oxide to oxygen. So we're going to have to go over the mole bridge, is what it's sometimes called. We need to take our grams of iron oxide and find out how many moles of iron oxide we have. We'll take our moles of iron oxide and find out how many moles of oxygen I need to make that much iron, and then we'll change it into Once we have moles of oxygen, we can change that using the molar mass into grams of oxygen. So let's write our equalities under each one. We'll first need the molar mass of iron oxide. So we've got 1 mole of iron oxide is 159.7 grams. We then know from this balanced equation, we're looking at iron oxide and oxygen, that 2 of the iron oxides are made for every 3 oxygens that enter the reaction. And these are moles. I didn't put that, but these are moles. Okay, and then lastly, we're going to want to take our moles of oxygen and change it to grams. We'll need the molar mass to do that. So we'll have 1 mole of O2 is equal to 1 atom of oxygen is 16, so 2 would be 32. This time I'm going to show you how you can stack them and make, this is the railroad track. So we'll start with the number in the problem. That's this number right here, right up here. You always want to make sure you don't get confused and use one of these conversions. Always start with the number from the problem. So if we've got 45.8 grams of iron oxide. I'm going to draw a long thing here. We've got lots of conversions to make. We're going to convert our grams of iron oxide into moles of iron oxide. We're going to use this equality right here. We want grams to disappear, so I'm going to put grams in the bottom. Our new units will be moles of iron oxide. That's our first conversion. Now, instead of solving for that, I'm just going to put the next conversion beside it. So here's our next conversion. We're taking our moles of iron oxide and changing it to moles of O2. So we want to lose our moles of iron oxide, so I'll put those in the bottom. We've got 2 moles of iron oxide and 3 moles of O2. Now, instead of solving it, I'm still not going to solve it. I'm going to go ahead and put our next conversion. We want to get rid of our moles of oxygen and leave ourselves with grams of oxygen. I didn't put oxygen there, but so we'll put our 1 mole of O2 down here and our 32 grams of O2 on the top. Now let's look at the units on this. I'm going to get the red out. Okay, so we've got grams. This is also, I didn't put it in there, but grams of iron oxide cancels with grams of iron oxide. Moles of iron oxide cancels with moles of iron oxide. Moles of O2 cancels with moles of O2. Our final units are going to be grams of O2. Now to get our number, we'll take 45.8, multiply by 1, divide by 159.7, multiply by 3, divide by 2, multiply by 32. And that will give us our answer. And it should be 13.78 grams. So each one of these we've studied independently. You can go from, you know how to go from grams to moles, and you also know how to go from moles to grams. You just need to put this extra little bit in the middle and you can do these calculations.